I want to go over problems 11 and 12 because you can't really go over these things too much. Let's just go through the whole thing. Now we've got these 4 questions here, but I think the best order to answer them in is 1, 3, 4, and then 2, because answering 1, 3, and 4 is going to be the way to answer question number 2. So let's look at A. Now we have with A, you've got the clump of points here with a trend, and then the trend line appears to go in the direction of the unusual point. Okay, so the first question is, how is it unusual? Well, here is where approximately the mean of the x-coordinates is, right about here. In other words, the center of the majority of the points is where the mean of the x-coordinates is. So, in number 1, how is it unusual? Okay. The x-coordinate is far from x bar. It's far from the mean of the x-coordinates. Now notice this is also true in point B. It's somewhat true in point C. It's not true in point D. Now let's put these in here. Here is approximately the mean. Here is x bar for B. Here is x bar approximately. I'm just guessing. For C, and here is x bar for D. So in A, the point is definitely far from x bar. In B, the point is far from x bar. In C, it's a little bit far from x bar, but not like these other 2 points. These other 2 points not only are far from x bar, if you excluded them, they're far beyond the max. So if this point were left out, here is where the max would be of x sub max. Okay, and here's where the max is here. Okay, and with this over in C, now here's the min, x min. Okay, now this point, although it's somewhat away from x bar, it's within the min and the max. So it's not that far from x bar. Whereas these 2 points, being beyond the max of the rest of the points, makes them much more unusual in terms of being far from x bar. So this is a very important thing to consider, because it answers this question. The x-coordinate is far from x bar, the mean of the x-coordinates. Therefore, the point has high leverage. It is this characteristic, the x-coordinate is far from x bar, that gives a point high leverage. So, A has leverage. B, leverage. A lot. Okay, lot of leverage. Oops, that's lot spelled backwards. That's unusual. Okay. In C, a bit of leverage. Okay. In D, no leverage. Okay. Now, okay. Now, so this is all number one. The x coordinates far from x. Now, this is A, but we're kind of talking about all of them at the same time. Okay. Does it have high leverage? Okay, we answered that. For each one, A, B, C, and D. Let's keep doing it this way. Let's just talk about all four of them at the same time. We can contrast them that way. Okay. Now, does it have a residual? Okay. The more leverage, the less residual. The more residual, the less leverage. Why is that? Well, let's talk about that. A point with leverage, that is a point that is distant from the mean of the x coordinates of the rest of the points, of all the points, is going to draw points with leverage, draw the LSQR, least squares regression line, to them by means of leverage. Okay, now, so this point has high leverage because it has because it's out on the x, because it's separate from the x coordinates. Okay, this point has high leverage. This point has a bit of leverage, some leverage, not much. This point has no leverage. Why? Because it's close to x bar. The further you are from x bar, the more leverage. Okay? Therefore, this point has no residual. This point is going to have a small residual. This point will have somewhat of a bigger residual. And this point will have a very big residual. Okay, let's go over that again. This point, no residual. A lot of leverage, no residual. A lot of leverage, no residual. This point is going to draw, under other circumstances, if this point were excluded, here is what the line of best fit would look like. Okay? Where R would equal 0. We'll talk about that in a minute. With this point left in, the line of best fit is going to go like this. Okay? And it will draw the line of best fit, the LSQR, to it, the least squares regression line, and causing this point to have a small residual. This point will draw the line up to it a little bit, just a bit, because it doesn't have much leverage. It has some, but not very much. Normally the line would look like this, but because of this point being here, the line will be pulled up more like that. But this point will still have a big residual. This point will not affect the slope at all. Here's the slope going through here. So this point will have a large residual. That is the difference between, here's the LSQR. So the estimated the estimated, the y hat for this point is going to be quite different from the y for this point. The y hat for this point will be quite different than the actual y for this point. The y hat for this point and its actual y will be very close, and the y hat for this point and its actual y will be very close. So, does it have leverage, a large residual, or both? Okay. So, high leverage and a large residual are mutually exclusive. They are mutually exclusive. All right. Now, so I guess, all right, let's go on and answer 2. What the heck? Let's do them in the order that they have them, even though I'm not crazy about the order. What does influential mean? Let's talk about influence. 2. Influence. A point is influential if leaving it out changes the LSQR, especially B sub 1. Now remember, it's y hat equals B sub 0 plus B sub 1 times x. We're really interested in if the point changes B sub 1, the slope. We don't care so much if it changes B sub 0, the starting point. That's really, really less important. Why? Because B sub 0 is a function of B sub 1, right? B sub 0 equals y bar minus B sub 1 times x bar. Okay, so changing B sub 1 is the game changer, not B sub 0. And the slope tells us is where the variation is. So that's what we really care about. Okay, so a point is influential if leaving it out changes the LSQR, especially B sub 1. All right, let's look at point A. We leave it out. Do we change the LSQR, especially the slope? No. Why? Because this point is already in line with the LSQR that would exist if it weren't there. Okay? B. We leave it out. Let's cover it over. Here's the LSQR that would exist if we left the point out. Leaving it in, the slope changes. Okay? So it's influential. C, if we leave it out, does the LSQR change? Yes, it does. Not very much, though, but it does change. The slope would change. It would change a little bit. Okay, D, no influence. Why? Although, if you left it out, the y-intercept would change. That is, B sub 0 would change. Why is that? Because y bar would change. The mean of the y coordinates of all the rest of the points is somewhere around here. And this point is far from the mean of the y coordinates. Therefore, it will affect B sub 0 because it's going to change y bar. But we're not concerned with that very much. What we're really concerned with is changing the slope. So yes, B sub 0 will change because it will the y coordinate of this point will affect y bar. The x coordinate of this point will not affect x bar. So it's not going to affect B sub 1. But the y coordinate will affect will change y bar because it's away from the rest of the y coordinates. So that'll change b sub 0. All right, but we don't care about that. So this point is not influential. Not influential. It does not change the slope of the line. And so we'll go back and answer the rest of these questions. Okay, let's go. We can talk about 4 because we're talking about slope. Okay, so in A, the slope does not change. It stays the same. B, the slope is 0 without the point. With the point, it's negative. So the point would decrease if we leave the point in. If we leave it out, if we remove the point, the slope increases. It goes from negative to positive. In C, if we leave the point out, the slope would increase. If we leave it in, the slope is going to slightly decrease. And in D, the slope does not change. It stays the same. Okay. Now, that's slope. Let's talk about 3, correlation. So we talked about slope. Slope is done. Okay. Okay, so to go over it again. A, no change. B, the slope gets more negative. Okay, decreases or whatever. C, the slope decreases slightly. D, the slope does not change. Now let's talk about that was 4. Let's talk about correlation. 3, correlation. Now just to refresh our memories, R equals the sum of z sub x sub I times z sub y sub I over n minus 1. So unusual points are going to affect correlation. Strengthen it, weaken it, whatever, depending on if they're in line with the rest of the points or not. Okay, so here you have, in A, you have a point that is in line with the rest of the points and whose x and y coordinates are all apart from x bar and y bar. Okay, this point here in the middle, we're going to call it x comma y bar. That's where the center of the LSQR is. The midpoint of LSQR is x bar comma y bar. Okay, this point is in line with the rest of the points, and its x and y coordinates are large, extremely large, or they could be negative, they could be over here, whatever. Therefore, increase A makes correlation stronger. Why? Because we're putting in a large x and y pair. So it's a bigger number. So it's going to go into the sum. So x coordinate, so r is going to go up. Okay? Now, here, so let's say we started out with, if we leave this out, let's say r is about, I don't know, 0.7. If we put this point in, r is going, with this point, r would be like 0.8 or something like that. It's definitely going to go up. It's going to make it stronger. Now, this point in B, if the unusual point is excluded, r will approximately equal 0 because the slope of the line is 0. But if you include it, r is going to equal like, I don't know, minus 0.6 or something like that. Okay? So that's much stronger correlation, certainly much stronger than 0. Okay. Now, so the bigger the residual of a point, the more it weakens correlation. Okay, so the bigger the residual of a point, the more it weakens correlation. No residual, the smaller the residual of a point, the more it strengthens correlation. Okay, so the bigger the residual of a point, the more it weakens correlation. The smaller the residual of a point, the more it strengthens correlation. Okay, so in A, very small residual, leaving it out weakens correlation. Putting it in strengthens correlation. B, lots of leverage, small correlation, leaving it in strengthens correlation. Leaving it out weakens correlation. C, a big residual, small amount of leverage, leaving it in weakens correlation. Leaving it out strengthens correlation. D, no leverage, very large residual, leaving it in weakens correlation. Leaving it out strengthens correlation. Okay, so let's review that. A, high leverage, low residual, no influence, leaving it in strengthens correlation. Leaving it out weakens correlation. B, here's the unusual point, okay? High leverage, low residual, leaving it in strengthens correlation. Leaving it out weakens correlation. C, small leverage, large residual, leaving it in weakens correlation. Leaving it out strengthens correlation. Large residual, even if we leave it in, the residual would be pretty big. Okay? Point D, large residual, no leverage, leaving it in weakens correlation. Leaving it out strengthens correlation. All right, now let's go on. Here's really the same thing over again. Let's talk about we can talk about these 4 points together. Okay. Same sets of questions, but we'll talk about them in unison, but it's going to be pretty much the same thing. Okay. So, if we take this point out, here is the LSQR, okay? And here, approximately, is x bar, the mean of the x coordinates, okay? So this is 12A. It has high leverage. So it will tend, if we leave it in, here's the pivot point, it will tend to pull the LSQR towards it. Okay? So, now, here's a thing that's interesting. It's going to have high influence. But it's not going to have, it will have a somewhat large residual. Why is that? Well, it's not good because of the weight of all these other points. It's not going to have the point, the LSQR is not going to go completely to it like this. It's going to be pulled to it more like this, like that. Okay, so it'll have a somewhat large residual. So, in this case, it will make, it decreases the slope. And it's going to lower correlation. Why? Because of its residual. It's going to have a bigger residual than the rest of these points. Let's erase all this. His influence changes slope. Let me erase all this. Okay. We exclude it. Here's the LSQR. Okay. R is going to be pretty high, like 0.85 or something like that, I'm estimating. But these residuals, look at these residuals here. They're all small residuals, okay? So the R is going to be 0.8, 0.85, maybe even higher than that, okay? Throwing in this point here, adding this influential point, if we estimate the pivot point here, that is x bar comma y bar, the center of the where the mean of the x and y coordinates is, then the line, this point is going to pivot around that point like so, like that. And we will end up with a point probably with the largest residual, but really changes the slope of the line. Lowers slope, lowers R. Lowers R. Lowers R. Okay. So here you have a situation in which a point can have fairly large residual. It has high leverage. It has high influence. It decreases the slope and it lowers correlation. It does all of these at the same time. All right. Let's talk about B. Okay, let's talk about what happens if we leave this point out. This would be the LSQR. And here approximately would be X bar comma Y bar, the center of the distribution, right about here. Okay? And R would equal 0. This is leaving it out. Okay? Now, if we leave it in, the LSQR is going to look like this. This point, right here, leaving this in, has a low residual, high influence. Why? Because it changes the slope. Increases slope. And increases R, makes R much stronger. R is going from R increases to I don't know what, but definitely much bigger than 0. Okay, so it's going to go, R is going to go up. Slope goes up, okay, and R goes up. So this point has high leverage, okay, low residual, high influence. It increases the slope, and it increases R. Okay, C. Let's place approximately here is X bar comma Y bar. All right. This point has a high residual. Okay. No leverage because it's very close to the mean of the x coordinates. So which is right about, so X bar is right about here, Y bar is right about here. Okay. So it's a high residual, no leverage, no influence, slope stays the same, and R gets weaker. R gets weaker. R will decrease in this case. But let's just think about gets weaker. If you think of it from the point of view of R squared gets weaker. Why? The bigger the residual, the weaker that R is. The smaller the residual, the stronger that R is. Okay, small residuals make strong R. Big residuals make for a weak R. Okay, finally, let's put, here is X bar comma Y bar. Here's the center of the distribution. Mean of the X's, mean of the Y, somewhat in here. Okay. Now, this point is far from X bar, has high leverage because it's far from X bar. Now, it will pull the LSQR to it. It has a very low residual. So it will increase R. It will make correlation stronger, but slope stays the same. So it's not influential. It does not change the slope of the line, so it's not influential. So let's go back over this. Okay, it has high leverage because it's far from X bar. It's in line with the rest of the points, so the LSQR is probably going to go right through it. So it will have a very, very low residual, probably lower than the residuals of the rest of these points. Therefore, it will increase R. The slope will stay the same. It's not influential. It does not change the slope. Okay, so that's it for 11 and 12.